Space is a paradox, a realm of breathtaking beauty and unimaginable danger, where the cosmos dances in a delicate balance of light and shadow. It's a place where the most stunning vistas can hide deadly secrets, and where humanity's fascination with the unknown has driven us to explore its farthest reaches. From the swirling storms of distant gas giants to the eerie glow of dying stars, space is a canvas painted with both wonder and peril. But what makes these places so mesmerizing yet so treacherous? Why do they captivate our imagination while reminding us of the fragility of life? In this journey, we'll uncover the most beautiful and dangerous places in the universe, where the line between awe and fear blurs. Together, we'll explore the science behind these cosmic wonders, the risks they pose, and the stories they tell about the universe we call home. Get ready for an adventure that will leave you in awe and maybe a little cautious as we dive into the heart of the cosmos. Among the countless wonders of the cosmos, nebulas stand out as the universe's most breathtaking art galleries. Imagine vast clouds of gas and dust stretching across light years, painted in hues of crimson, gold, and deep blue. These ethereal shapes, sculpted by the forces of gravity and radiation, are more than just cosmic eye candy. They're the cradles of creation where stars are born. Take the Orion Nebula, for instance, a glowing tapestry of light visible even to the naked eye. Or the Carina Nebula, a swirling masterpiece of cosmic dust and newborn stars, so vivid it feels like stepping into a dream. But don't let their beauty fool you. Within these celestial nurseries, danger lurks. Intense radiation floods the space, capable of sterilizing planets or frying any spacecraft that dares to venture too close. Gravitational forces, powerful enough to crush matter into new stars, could just as easily tear apart anything that strays into their grasp. Nebulas are a reminder that the universe is both a creator and a destroyer, a place where life and chaos dance in perfect, perilous harmony. And as we marvel at their splendor, we're left to wonder what other wonders and dangers lie hidden in the depths of space. Picture this, a star millions of times larger than our sun, reaching the end of its life in a cataclysmic explosion so powerful it outshines entire galaxies. This is a supernova, a cosmic event that marks both the death of a star and the birth of something extraordinary. In a matter of seconds, a supernova releases more energy than our sun will produce in its entire lifetime, lighting up the darkness of space with a brilliance that defies imagination. But this isn't just a spectacle of destruction. Supernovas are cosmic alchemists forging the very elements that make life possible. The iron in your blood, the calcium in your bones, even the oxygen you breathe, all of these were born in the heart of dying stars, scattered across the universe in the aftermath of these colossal explosions. Take the Crab Nebula, for example. This glowing remnant of a supernova that lit up Earth's skies in the year 1054 is a masterpiece of cosmic artistry. Its swirling tendrils of gas, painted in hues of pink, blue, and gold, are a testament to the beauty that can emerge from chaos, but don't let its serene appearance fool you. The Crab Nebula is a powerhouse of radiation with a pulsar at its core spinning 30 times per second, sending out beams of energy that could vaporize anything in their path. Supernovas are as dangerous as they are dazzling. The sheer force of these explosions can obliterate nearby planets, sterilizing entire star systems in an instant. Even from thousands of light years away, a supernova's gamma-ray burst could pose a threat to life on Earth, stripping away our protective ozone layer and exposing the planet to deadly radiation. Yet, without these violent events, the universe as we know it wouldn't exist. They are the ultimate paradox destroyers and creators, leaving behind not just remnants of destruction, but the seeds of new worlds and new possibilities. And speaking of remnants, the aftermath of a supernova holds its own mysteries. From the glowing clouds of gas to the dense cores left behind, these cosmic relics tell stories of what once was and what could be. But what happens when the dust settles and the fireworks fade? That's where our journey takes us next, into the strange and fascinating world of neutron stars and black holes. When a massive star collapses, it doesn't always fade quietly into the cosmic void. Instead, it leaves behind one of the most extreme and fascinating objects in the universe, a neutron star. Imagine taking the entire mass of our Sun and squeezing it into a sphere no larger than a city. That's the mind-bending density of a neutron star. These stellar remnants are so compact that a single sugar cube-sized piece of their surface would weigh billions of tons. To put it another way, if you could somehow scoop up a teaspoon of neutron star material, it would outweigh Mount Everest. But neutron stars aren't just dense, they're also dynamic. Many of them spin at incredible speeds, rotating hundreds of times per second. This rapid spin, combined with their intense magnetic fields, can turn them into cosmic lighthouses, emitting beams of radiation that sweep across the universe. These beams, known as pulsars, are so precise that they rival the accuracy of atomic clocks. Yet, for all their mesmerizing qualities, neutron stars are anything but welcoming. Their gravitational pull is so strong that it warps the fabric of space-time, creating a force field that could shred anything that comes too close. And if that weren't enough, their surfaces are bathed in deadly radiation, capable of frying any spacecraft or planet in their vicinity. Neutron stars are a testament to the extremes of the cosmos, where the laws of physics are pushed to their limits. They're a reminder that even in the aftermath of a star's death, the universe continues to surprise us with its ingenuity. But as extreme as neutron stars are, they're not the end of the story. Under the right conditions, these dense remnants can collapse even further, giving rise to something even more mysterious and terrifying, a black hole. And that's where our journey takes us next, into the heart of one of the universe's most enigmatic and dangerous phenomena. Black holes are the ultimate cosmic predators, lurking in the darkness of space with a gravitational grip so strong that not even light can escape their clutches. Picture the event horizon, the point of no return where the laws of physics as we know them break down and the fabric of space-time twists into a one-way street. It's a place where the universe's rules are rewritten and where the unimaginable becomes reality. These enigmatic objects are born from the collapse of massive stars, their cores imploding under their own gravity after a supernova explosion. But black holes aren't just remnants of stellar death, they're architects of the cosmos. At the center of nearly every galaxy, including our own Milky Way, lies a supermassive black hole, millions or even billions of times more massive than our Sun. These titans shape the galaxies around them, influencing the orbits of stars and the flow of cosmic gas, and playing a crucial role in the evolution of the universe. Yet, for all their destructive power, black holes are also sources of breathtaking beauty. Surrounding many of them are accretion disks, glowing rings of superheated gas and dust spiraling inward at nearly the speed of light. These disks shine with an intensity that rivals the brightest stars, their light bending and warping as it dances around the black hole's gravitational well. It's a cosmic ballet of energy and matter, a spectacle that reminds us of the universe's capacity for both creation and destruction. But don't let their beauty deceive you. Black holes are as dangerous as they are mesmerizing. Venture too close and you'll experience spaghettification, a gruesome process where the black hole's immense gravity stretches you into a long, thin strand of atoms. Even from a distance, their gravitational pull can warp space-time, creating tidal forces that could tear apart planets or stars. And if you were to cross the event horizon, there's no turning back. Time itself would slow to a crawl, and the universe as you know it would fade into oblivion. Black holes are a paradox, a blend of beauty and terror, creation and destruction. They challenge our understanding of the universe and force us to confront the limits of human knowledge. But what lies beyond the event horizon? What secrets do these cosmic predators hold in their inky depths? To answer those questions, we must venture into the mysterious regions surrounding black holes, where the laws of physics are pushed to their breaking point. And that's where our journey takes us next. The event horizon of a black hole is like the edge of a cosmic waterfall, a boundary where the flow of space-time becomes so intense that escape is impossible. Imagine standing at the top of a waterfall, watching the water rush over the edge, pulled downward by an unstoppable force. Now replace the water with space itself, and you've got the event horizon. Once you cross this invisible line, there's no turning back. Not even light, the fastest thing in the universe, can outrun the black hole's gravitational pull. It's a one-way trip into the unknown where the familiar rules of physics no longer apply. But the event horizon isn't just a point of no return. It's also a stage for some of the most fascinating phenomena in the cosmos. Take time dilation, for example. As you approach the event horizon, time slows down relative to the outside universe. To an observer watching from a safe distance, it would seem as though you're frozen in place, forever hovering at the edge. Yet, from your perspective, time would pass normally, even as the universe around you speeds up. It's a mind-bending effect that challenges our understanding of reality. Then there's gravitational lensing, a phenomenon where the black hole's immense gravity bends the light from stars and galaxies behind it, creating a surreal, warped view of the cosmos. It's like looking through a cosmic magnifying glass where the black hole distorts and magnifies the light, revealing a kaleidoscope of distant worlds. This effect isn't just beautiful, it's also a powerful tool for astronomers, allowing them to study objects that would otherwise be hidden from view. Yet, for all its scientific intrigue, the event horizon is also a place of unimaginable danger. Crossing it would mean entering a realm where the laws of physics as we know them break down. The tidal forces near a black hole are so extreme that they can stretch and compress matter in a process called spaghettification. Imagine being pulled like taffy, your body elongated into a thin strand of atoms, until you're nothing more than a stream of particles spiraling into the abyss. It's a grim reminder of the raw power of these cosmic giants. And while the event horizon marks the boundary of a black hole's influence, the story doesn't end there. At the heart of nearly every galaxy lies a supermassive black hole, millions or even billions of times more massive than our Sun. These colossal objects don't just lurk in the shadows, they shape the very fabric of the universe around them. From influencing the orbits of stars to driving the formation of galaxies, supermassive black holes are cosmic architects, weaving the tapestry of the cosmos on a scale that's almost impossible to comprehend. As we peer into the depths of space, the event horizon serves as a gateway to understanding the universe's most extreme environments. It's a place where beauty and danger collide, where the laws of physics are pushed to their limits, and where the mysteries of the cosmos unfold in ways that continue to captivate and challenge us. And as we explore further, we'll uncover even more about these enigmatic objects and their role in the grand story of the universe. At the heart of nearly every galaxy, including our own Milky Way, lies a cosmic titan, a supermassive black hole. These galactic giants are unlike anything else in the universe, with masses millions or even billions of times greater than our Sun. Imagine a gravitational force so immense that it can hold entire galaxies together, dictating the orbits of stars and shaping the very fabric of space-time around it. These black holes are not just passive observers of the cosmos, they are active players, driving the evolution of galaxies and influencing the fate of countless stars. One of the most striking features of supermassive black holes is their ability to power quasars, the brightest objects in the universe. Picture a swirling disk of gas and dust, heated to unimaginable temperatures as it spirals into the black hole's maw. This disk glows with such intensity that it can outshine entire galaxies, lighting up the darkness of space with a brilliance that can be seen across billions of light years. Quasars are like cosmic lighthouses, their beams cutting through the void and offering us a glimpse into the early universe. Yet, for all their beauty, quasars are also a reminder of the raw power of supermassive black holes, capable of consuming stars and devouring entire solar systems. But the influence of supermassive black holes extends far beyond their immediate surroundings. Their gravitational pull can disrupt galactic structures, flinging stars into chaotic orbits or even ejecting them from their galaxies entirely. In some cases, the collision of two galaxies can trigger a feeding frenzy, as their central black holes merge and release bursts of energy that ripple through the cosmos. These events are both destructive and creative, tearing apart old structures while seeding the formation of new ones. Despite their fearsome reputation, supermassive black holes are also essential to the story of the universe. They play a crucial role in the formation and evolution of galaxies, acting as cosmic anchors that shape the flow of gas and stars. Without them, the universe as we know it might look very different. And as we continue to study these enigmatic objects, we uncover more about their role in the grand tapestry of the cosmos, a tapestry woven with threads of light, gravity, and time. As we delve deeper into the mysteries of supermassive black holes, we begin to see how they are not just destroyers but also creators. Their influence stretches across the universe, shaping galaxies and driving the processes that make life possible. And as we explore further, we'll uncover even more about these galactic giants and the profound impact they have on the cosmos. At the heart of every galaxy lies a spectacle of light, motion, and raw power, a galactic center. These cosmic hubs are where the universe's most dramatic forces converge, creating environments that are as breathtaking as they are deadly. Imagine a swirling dance of stars packed so tightly that their combined light outshines the rest of the galaxy. Glowing clouds of gas spiral inward, heated to millions of degrees as they're pulled toward the supermassive black hole lurking at the core. It's a place where the laws of physics are pushed to their limits, and where the beauty of creation is matched only by the danger of destruction. Take the center of our own Milky Way, for example. Here, stars orbit the supermassive black hole known as Sagittarius, a star at breakneck speeds, some reaching velocities of thousands of kilometers per second. The gravitational forces at play are so intense that they warp the fabric of space-time, creating a chaotic yet mesmerizing ballet of light and motion. Surrounding this central black hole is a dense cluster of stars, their combined glow illuminating the galactic core with a brilliance that can be seen from across the universe. But this beauty comes at a cost. The galactic center is a place of extreme radiation, where X-rays and gamma rays flood the space, making it inhospitable to life as we know it. Stars here are often born in violent bursts, their formation triggered by the gravitational tug of war between the black hole and the surrounding gas clouds. And when stars die, they do so in spectacular fashion, their supernova adding to the already intense radiation environment. It's a cosmic pressure cooker where the forces of creation and destruction are locked in an eternal struggle. Yet, even in this chaotic environment, there's a strange kind of order. The supermassive black hole acts as a gravitational anchor, holding the galaxy together and shaping the orbits of stars and gas clouds. Without it, the galaxy would fly apart, its stars scattered into the void. But with it, the galactic center becomes a place of both danger and opportunity, a crucible where new stars are forged and where the universe's most extreme phenomena play out on a grand scale. As we move away from the galactic center, the density of stars and gas begins to thin, but the universe still has surprises in store. Beyond the reach of supermassive black holes and dense star clusters, there's another kind of cosmic wanderer, rogue planets. These lonely worlds, untethered from any star, drift through the darkness of space, their origins as mysterious as their destinations. And it's here, in the vast emptiness between stars, that our journey takes its next turn. In the vast emptiness between stars, where the light of distant suns fades into darkness, there exists a peculiar kind of wanderer, a rogue planet. Picture a world untethered from any star, drifting silently through the void, its icy surface glinting faintly in the starlight. These lonely worlds, born from the chaos of collapsing star systems or flung into the abyss by gravitational encounters, are the nomads of the cosmos. Without a sun to warm them, they are cloaked in perpetual twilight, their surfaces frozen and desolate. Yet, even in their isolation, rogue planets hold secrets that challenge our understanding of life and the universe. How do these wandering worlds come to be? Some are ejected from their star systems during the chaotic dance of planetary formation, while others may form directly from the collapse of interstellar gas clouds, never knowing the warmth of a parent star. Despite their frigid exteriors, some rogue planets might harbor hidden oceans beneath their icy crusts, kept liquid by the heat of radioactive decay or tidal forces. These subsurface oceans could potentially support life, thriving in the darkness far from any star. Imagine a world where life exists not under a sunlit sky, but in the depths of an eternal night, sustained by the planet's internal warmth. The beauty of rogue planets lies in their stark, otherworldly landscapes. Their surfaces, coated in layers of ice and frozen gases, might shimmer with faint auroras created as cosmic rays interact with their thin atmospheres. These ghostly lights dancing across the horizon would be the only source of illumination on a world where the sun never rises. It's a hauntingly beautiful vision, a planet adrift in the void, its icy plains glowing faintly under the light of distant stars. But life on a rogue planet, if it exists, would face unimaginable challenges. The extreme cold, often plunging to hundreds of degrees below zero, would make survival nearly impossible on the surface. The absence of a star means no sunlight to drive photosynthesis or warm the planet's surface, and the isolation billions of miles from the nearest star would make these worlds some of the loneliest places in the universe. Yet, in the face of such adversity, the possibility of life beneath the ice reminds us of the resilience and adaptability of nature. As we contemplate the mysteries of rogue planets, we're reminded that the universe is full of surprises, even in its most desolate corners. These wandering worlds, with their icy beauty and hidden potential, challenge our assumptions about where life might exist. But the cosmos has more wonders in store, some of them far more turbulent. From the silent drift of rogue planets, we turn our gaze to the violent storms of gas giants, where chaos reigns and the skies are alive with fury. Among the countless wonders of our solar system, few are as iconic or as enduring as Jupiter's Great Red Spot. This colossal storm, larger than Earth itself, has been raging for centuries, a swirling vortex of crimson and white clouds that dominates the face of the gas giant. From a distance, it looks almost serene, a hypnotic swirl of color against Jupiter's striped atmosphere. But up close, it's a maelstrom of unimaginable power, a testament to the raw energy that drives the weather on gas giants. The Great Red Spot is more than just a storm. It's a window into the chaotic heart of Jupiter. Its vibrant colors come from the complex chemistry of the planet's atmosphere, where compounds like ammonia and sulfur rise and fall, reacting with sunlight to create hues of red, orange, and white. The storm itself is a high-pressure system, spinning counterclockwise like a cosmic whirlpool, with winds reaching speeds of up to 400 miles per hour. To put that into perspective, the strongest hurricanes on Earth top out at around 200 miles per hour. The Great Red Spot is in a league of its own, a tempest that could swallow our planet whole and still have room to spare. But what keeps this storm going for so long? Unlike Earth's weather systems, which are driven by the sun's heat and the planet's rotation, Jupiter's storms are fueled by the planet's internal heat. Deep beneath its clouds, Jupiter radiates more energy than it receives from the sun, creating a turbulent atmosphere where storms can rage for centuries. The Great Red Spot is a product of this relentless energy, a self-sustaining vortex that shows no signs of slowing down. Yet, for all its beauty, the Great Red Spot is also a place of extreme danger. The winds within the storm are strong enough to tear apart anything that ventures too close, and the pressure is so intense that it could crush a spacecraft like a tin can. Even from a safe distance, the storm's sheer scale is humbling, a reminder of the power and unpredictability of the universe. Jupiter isn't the only gas giant with a penchant for extreme weather. Saturn, with its hexagonal polar storm and swirling jet streams, is another example of the wild weather found on these massive planets. Neptune, too, boasts some of the fastest winds in the solar system, with gusts reaching over 1,000 miles per hour. These storms are more than just cosmic curiosities. They're a glimpse into the complex dynamics of gas giants, where the interplay of heat, rotation, and atmospheric chemistry creates some of the most dramatic weather in the universe. As we marvel at the storms of gas giants, we're reminded of the diversity and dynamism of our solar system. From the serene beauty of swirling clouds to the raw power of hurricane-force winds, these planets are a testament to the forces that shape the cosmos. And as we turn our gaze beyond the gas giants, we'll explore another kind of cosmic phenomenon, one that's as mysterious as it is beautiful. Saturn's North Pole holds one of the most enigmatic and mesmerizing features in our solar system, a perfect hexagon, etched into the planet's atmosphere like a cosmic snowflake. This six-sided storm, large enough to fit 4 Earths side by side, is a geometric wonder that defies expectations. Unlike the chaotic swirls of Jupiter's Great Red Spot, Saturn's hexagon is a study in symmetry, its sharp edges and precise angles standing out against the planet's golden haze. It's as if nature itself decided to paint a masterpiece using the laws of physics as its brush. The hexagon's swirling clouds, a mix of pale yellows and deep blues, create a hypnotic pattern that seems almost too perfect to be real. But this isn't just a static shape, it's a dynamic storm, with winds racing at speeds of over 300 miles per hour. These winds whip around the hexagon's edges, creating a boundary that keeps the storm's structure intact. It's a delicate balance of chaos and order, where the forces of nature come together to form something both beautiful and baffling. So, how does such a precise shape emerge in the turbulent atmosphere of a gas giant? Scientists believe the hexagon is the result of complex interactions between Saturn's atmospheric currents and its rapid rotation. The planet spins so quickly, completing a full rotation in just 10.5 hours, that its atmosphere is stretched and shaped by the Coriolis effect, the same force that creates Earth's hurricanes. In Saturn's case, this effect may generate standing waves that lock the storm into a hexagonal pattern. Another theory suggests that the hexagon is a type of atmospheric jet stream, its shape stabilized by the planet's unique fluid dynamics. But while the hexagon's formation is still a subject of debate, one thing is certain: it's a place of extreme conditions. The winds within the storm are powerful enough to shred anything that ventures too close, and the pressure is so intense that it could crush even the sturdiest spacecraft. For all its beauty, Saturn's hexagon is a reminder of the raw power that lies beneath the serene appearance of gas giants. As we marvel at this geometric marvel, we're reminded that Saturn is more than just its iconic rings. The planet's atmosphere is a dynamic and ever-changing environment where storms rage and mysteries abound. And just beyond the hexagon's swirling clouds lies another realm of wonder: the icy moons that orbit Saturn, each with its own unique story to tell. From the geysers of Enceladus to the methane lakes of Titan, these moons are worlds unto themselves, offering glimpses into the diversity and complexity of our solar system. And it's here, among these frozen satellites, that our journey continues. Europa, one of Jupiter's most intriguing moons, is a world of icy mystery and tantalizing potential. Its surface, a gleaming expanse of frozen water, is crisscrossed with intricate patterns of cracks and ridges, like a mosaic of frost etched into the void of space. These features aren't just random, they're clues to what lies beneath. Scientists believe Europa hides a vast subsurface ocean, locked beneath an icy shell that could be miles thick. This ocean, warmed by the gravitational tug of war between Europa and Jupiter, might hold more liquid water than all of Earth's oceans combined, and where there's water, there's the possibility of life. The idea of life on Europa is both thrilling and humbling. Imagine a dark, watery world untouched by sunlight, where life could thrive in the warmth of hydrothermal vents or in the cracks of the icy crust. Microorganisms, or perhaps even more complex creatures, could exist in this alien environment, adapted to the extreme conditions of a moon far from the sun's warmth. It's a reminder that life, as we know it, might not be confined to Earth, that the universe could be teeming with possibilities we've yet to discover. But Europa's beauty comes with a price. Its surface is one of the coldest places in the solar system, with temperatures plunging to -260 degrees Fahrenheit. The icy crust is bombarded by intense radiation from Jupiter, making the surface a hostile environment for any spacecraft or life. Even so, the cracks and ridges on Europa's surface suggest that the ice is dynamic, shifting and cracking as the moon is stretched and squeezed by Jupiter's gravity. These movements could create pathways for nutrients and heat to reach the ocean below, potentially supporting life in ways we're only beginning to understand. Exploring Europa is no small feat. Its icy shell is a formidable barrier, and the radiation from Jupiter poses a serious challenge to any mission. Yet the potential rewards are immense. If life exists beneath Europa's ice, it could revolutionize our understanding of biology and our place in the universe. Missions like NASA Europa Clipper aim to study this enigmatic moon up close, searching for signs of habitability and perhaps even life itself. As we ponder the mysteries of Europa, we're reminded that the universe is full of surprises. From its icy surface to the hidden ocean below, this moon is a testament to the resilience and adaptability of nature. But Europa isn't the only moon in Jupiter's orbit with a story to tell. Just a short cosmic journey away lies Io, a world of fire and fury, where volcanoes erupt with such intensity that they reshape the moon's surface in real time. And it's there, in the heart of Jupiter's volcanic moon, that our journey takes its next turn. Io, Jupiter's innermost large moon, is a world of fire and chaos, a place where the ground itself seems alive with fury. Unlike the icy serenity of Europa, Io is a volcanic inferno, its surface painted in vivid hues of yellow, red, and orange colors born from sulfur and molten lava. This moon is the most geologically active body in the solar system, with over 400 active volcanoes dotting its landscape. Some of these volcanoes spew plumes of sulfur and silicate rock hundreds of miles into space, creating a spectacle that's as beautiful as it is terrifying. What makes Io such a volcanic powerhouse? The answer lies in its relationship with Jupiter. Io is caught in a gravitational tug of war between the massive planet and its neighboring moons, Europa and Ganymede. These tidal forces stretch and squeeze Io's interior, generating immense heat through friction. This heat melts rock, creating vast reservoirs of magma that erupt violently onto the surface. It's a constant cycle of destruction and renewal, with lava flows reshaping the moon's landscape in real time. The beauty of Io is undeniable. Its surface is a patchwork of volcanic plains, towering mountains, and calderas, giant craters formed by collapsing magma chambers. The sulfur compounds give the moon its striking colors, creating a surreal, almost alien palette. But don't let its vibrant appearance fool you. Io is one of the most hostile places in the solar system. Temperatures near its volcanoes can reach thousands of degrees, and the atmosphere is filled with toxic gases like sulfur dioxide. Any spacecraft venturing too close would face a barrage of radiation, extreme heat, and corrosive chemicals. Yet, despite its dangers, Io offers a unique window into the forces that shape planetary bodies. Its volcanic activity provides clues about the internal dynamics of moons and planets, helping scientists understand how tidal forces can drive geological processes. Io is a reminder that even in the cold void of space, there are places where the ground burns and the skies are filled with fire. As we leave Io's fiery landscape behind, we're reminded that Jupiter's moons are a study in contrast. From the icy oceans of Europa to the volcanic chaos of Io, each moon tells a different story about the forces that shape our solar system. And beyond Jupiter, there are even more worlds waiting to be explored, each with its own unique blend of beauty and danger. Beyond the fiery chaos of Io lies a world that feels almost familiar yet utterly alien: Titan, Saturn's largest moon. Imagine a landscape where rivers carve through valleys, lakes stretch across vast plains, and clouds drift lazily through a hazy orange sky. At first glance, Titan could almost pass for Earth until you realize those rivers and lakes aren't filled with water, but with liquid methane and ethane. This is a world where the chemistry of life as we know it is turned upside down, where the building blocks of existence are forged not in water but in hydrocarbons. Titan's atmosphere is a thick, nitrogen-rich shroud, tinged with an orange hue from the complex organic molecules that float within it. Sunlight filters through this haze, casting an eerie glow over the moon's surface. It's a place of surreal beauty where the interplay of light and shadow creates landscapes that feel both alien and strangely familiar. Towering dunes of hydrocarbon sand stretch across equatorial regions, while icy mountains rise in the distance, their peaks glinting faintly in the dim light. But what truly sets Titan apart are its lakes and rivers. These aren't just small puddles. Some of Titan's lakes are as large as the Great Lakes on Earth, filled with liquid methane and ethane that flows and evaporates in a cycle eerily reminiscent of Earth's water cycle. The largest of these, Kraken Mare, is a sprawling body of liquid hydrocarbons that could rival the Caspian Sea in size. Picture standing on its shores, watching waves of methane lap against the icy coastline, under a sky that glows with an otherworldly light. Yet for all its beauty, Titan is a place of extreme danger. The surface temperature hovers around -290 degrees Fahrenheit, cold enough to freeze water instantly. The atmosphere, while thick, is toxic to humans, composed mostly of nitrogen with traces of methane and other hydrocarbons. Any spacecraft landing on Titan would need to withstand not only the crushing cold but also the corrosive effects of its atmosphere. Despite these challenges, Titan holds tantalizing possibilities for life, just not as we know it. The moon's methane-based chemistry could support exotic forms of life, organisms that thrive in the absence of water and use methane as their solvent. These hypothetical life forms would be fundamentally different from anything on Earth, adapted to a world where the rules of biology are rewritten. As we marvel at Titan's strange beauty and ponder the mysteries it holds, we're reminded that the universe is full of worlds that defy our expectations. From the icy plains of Europa to the methane lakes of Titan, each moon tells a unique story about the diversity of our solar system, but the wonders of the cosmos don't end here. Beyond our own celestial neighborhood, there are countless exoplanets, worlds orbiting distant stars, each with its own unique blend of beauty and danger. And it's there, in the vast expanse of the galaxy, that our journey takes its next turn. Beyond the familiar worlds of our solar system lies a vast and uncharted frontier: exoplanets. These distant worlds, orbiting stars light years away, have transformed our understanding of the universe. Since the first confirmed discovery in the early 1990s, astronomers have identified thousands of exoplanets, each one a unique testament to the diversity of the cosmos. From scorching hot Jupiters to icy super-Earths, these alien worlds offer a glimpse into the infinite possibilities of planetary formation. Picture a planet so close to its star that its surface is molten rock, glowing like embers in the darkness of space. Or imagine a frozen super-Earth where oceans of liquid water might lie beneath miles of ice, hidden from the light of a distant sun. Some exoplanets are shrouded in thick, toxic atmospheres, while others are bathed in perpetual twilight, tidally locked to their stars with one side always facing the heat and the other plunged into eternal cold. These worlds are as varied as they are mysterious, each one a canvas painted with the brushstrokes of gravity, chemistry, and time. But how do we find these distant worlds? One of the most common methods is transit photometry, where astronomers measure the slight dimming of a star's light as a planet passes in front of it. Another technique, radial velocity, detects the subtle wobble of a star caused by the gravitational pull of an orbiting planet. These methods, along with others like direct imaging and gravitational microlensing, have opened a window into the cosmos, revealing a universe teeming with planets. Yet, for all their beauty, exoplanets are often places of extreme danger. Many orbit so close to their stars that their surfaces are scorched by intense radiation, while others are so far away that they're frozen wastelands. Some have atmospheres thick with toxic gases, making them inhospitable to life as we know it. Even the most Earth-like exoplanets discovered so far, those in the so-called habitable zone, face challenges like tidal locking, extreme weather, or volatile geological activity. As we marvel at the diversity of exoplanets, we're reminded that the universe is full of surprises. These distant worlds challenge our assumptions and expand our imagination, offering a glimpse into the infinite possibilities of planetary systems. But among the thousands of exoplanets discovered, some stand out as truly extreme worlds that push the boundaries of what we thought was possible. And it's there, in the realm of the most extreme exoplanets, that our journey takes its next turn. Among the countless exoplanets scattered across the galaxy, some stand out as true extremes, worlds where the laws of physics and chemistry create environments that are both stunning and terrifying. These are the hellish exoplanets, places where fire and ice reign supreme, and where the beauty of the cosmos is matched only by its brutality. Take, for example, the lava worlds, planets so close to their stars that their surfaces are molten oceans of rock. Picture a planet where the ground glows red-hot, rivers of lava carving through the landscape under a sky filled with ash and fire. These worlds are like something out of a science fiction novel, their surfaces constantly reshaped by volcanic activity and tidal forces. The heat is so intense that metals like iron and nickel would melt instantly, creating a surreal, glowing terrain that defies imagination. On the opposite end of the spectrum are the frozen wastelands, planets so far from their stars that they're locked in perpetual ice. Imagine a world where the temperature never rises above -300 degrees Fahrenheit, where the atmosphere has frozen solid and the surface is a barren expanse of ice and snow. These icy exoplanets are hauntingly beautiful, their surfaces glinting faintly in the dim light of a distant sun. Yet, beneath their frozen exteriors, some may hide oceans of liquid water, kept warm by the planet's internal heat or the gravitational pull of a nearby moon. The formation of these extreme worlds is a testament to the diversity of planetary systems. Lava worlds often form close to their stars, where the intense heat strips away their atmospheres and melts their surfaces. Frozen wastelands, on the other hand, are born in the outer reaches of their systems, where the cold preserves their icy crusts and slows their geological activity. Both types of planets are shaped by the same forces: gravity, heat, and chemistry, but the results couldn't be more different. Yet, for all their beauty, these worlds are places of extreme danger. Lava worlds are bombarded by intense radiation from their stars, their surfaces constantly reshaped by volcanic eruptions and tidal forces. Frozen wastelands, meanwhile, are cloaked in darkness, their surfaces bombarded by cosmic rays and their atmospheres too thin to support life as we know it. Even the most resilient spacecraft would struggle to survive in these environments, where the conditions are as harsh as they are beautiful. As we explore these extreme exoplanets, we're reminded of the delicate balance that makes life on Earth possible. The search for habitable worlds, planets within the so-called Goldilocks zone, where temperatures are just right for liquid water, has become one of the most exciting frontiers in astronomy. These Earth-like planets, with their potential for life, offer a stark contrast to the hellish worlds of fire and ice. And as we turn our gaze toward these distant possibilities, we're reminded that the universe is full of surprises, each one a new chapter in the story of the cosmos. In the vast expanse of the cosmos, there's a special region around stars that astronomers call the Goldilocks zone, a place where conditions are just right for liquid water to exist. Not too hot, not too cold, but just the perfect balance to make life as we know it possible. This habitable zone is where the search for Earth-like exoplanets takes center stage, offering a tantalizing glimpse into worlds that might one day reveal the secrets of life beyond our solar system. Imagine a planet bathed in the gentle glow of its star, with oceans shimmering under a hazy blue sky. These Earth-like exoplanets, with their potential for liquid water and stable atmospheres, are the holy grail of modern astronomy. Some might have vast continents and deep oceans, while others could be covered in lush vegetation or swirling clouds. The beauty of these worlds lies not just in their landscapes, but in the possibility that they could harbor life, a thought that stirs both wonder and curiosity. But finding these worlds is no easy task. Detecting life on distant exoplanets requires more than just spotting a planet in the habitable zone. Scientists must analyze the planet's atmosphere, looking for telltale signs like oxygen, methane, or even industrial pollutants that could hint at biological activity. This process, known as spectroscopy, involves studying the light that passes through a planet's atmosphere, breaking it down into a spectrum that reveals its chemical composition. It's like reading the fingerprints of a distant world, searching for clues that might point to life. Yet, even in the Goldilocks zone, danger lurks. Many stars, especially younger ones, are prone to violent outbursts called stellar flares, sudden bursts of radiation that can strip away a planet's atmosphere or fry its surface. Cosmic radiation, too, poses a threat, bombarding planets with high-energy particles that could make life difficult, if not impossible. And then there's the challenge of tidal locking, where a planet's rotation becomes synchronized with its orbit, leaving one side perpetually scorched by the star's heat and the other frozen in eternal darkness. Despite these challenges, the search for habitable worlds continues to captivate scientists and dreamers alike. Each new discovery brings us closer to answering one of humanity's oldest questions. Are we alone in the universe? And as we peer into the depths of space, we're reminded that the cosmos is full of surprises, from the serene beauty of Earth-like exoplanets to the violent forces that shape their destinies. But the story of the universe isn't just about the birth of stars and planets, it's also about their dramatic ends. From the fiery explosions of supernovas to the enigmatic collapse of black holes, the deaths of stars are as awe-inspiring as their births. And it's there, in the final moments of stellar life, that our journey takes its next turn. The life of a star is a cosmic epic, a story that spans billions of years and unfolds in stages as dramatic as they are beautiful. It all begins in the heart of a nebula, a vast cloud of gas and dust where gravity begins to pull matter together. Over time, these clumps grow denser and hotter, until the pressure at their cores ignites nuclear fusion, the spark that gives birth to a star. This newborn star, called a protostar, glows faintly at first, its light struggling to pierce the surrounding dust. But as it grows, it begins to shine brighter, carving out its place in the cosmos. As the star matures, it enters the main sequence phase, where it spends the majority of its life. Here, it burns hydrogen into helium, releasing energy that radiates outward in a steady, life-giving glow. Our own sun is in this stage, a stable and reliable source of light and warmth. But not all stars are so fortunate. Massive stars, many times larger than our sun, burn through their fuel at a furious pace, their lives marked by brilliance and brevity. Eventually, even the most stable stars begin to change. As their hydrogen supply dwindles, they expand into red giants, swelling to hundreds of times their original size. These aging stars are a sight to behold, their surfaces glowing with a deep, reddish hue as they shed their outer layers into space, but this beauty comes at a cost. The expansion of a red giant can engulf nearby planets, and the intense heat and radiation make these regions hostile to life. For the most massive stars, the end is even more dramatic. When their cores can no longer sustain fusion, they collapse under their own gravity, triggering a supernova, a cataclysmic explosion that outshines entire galaxies. These events are both destructive and creative, scattering heavy elements like iron and gold across the cosmos and seeding the universe with the building blocks of new stars and planets. But not all stars meet such a fiery end. Smaller stars like our Sun fade more gently. After shedding their outer layers, their cores remain as white dwarfs, dense, Earth-sized remnants that glow faintly with the heat of their fading energy. These stellar embers are the quiet survivors of the cosmos, slowly cooling over billions of years until they fade into darkness. The life cycle of a star is a testament to the forces that shape the universe. From the birth of a protostar to the explosive death of a supernova, each stage reveals the delicate balance of gravity, heat, and time. And as we explore these cosmic processes, we're reminded that even the stars themselves are part of a larger story, one that continues to unfold in the vast expanse of space. But the journey doesn't end with white dwarfs. These stellar remnants play a crucial role in the cosmos, often serving as the final resting place for planetary systems or the seeds of new celestial phenomena. And as we turn our gaze to these quiet yet significant objects, we'll uncover even more about the intricate dance of creation and destruction that defines the universe. White dwarfs are the quiet survivors of the cosmos' stellar remnants that glow faintly, like embers cooling in the ashes of a once bright fire. These dense, Earth-sized objects are what stars like our Sun become after they've exhausted their nuclear fuel and shed their outer layers. Imagine a star that once shone brightly, now reduced to a dense core, radiating a soft, pale light as it slowly fades into the darkness of space. It's a poignant reminder that even the most enduring stars must eventually come to an end. The formation of a white dwarf is a delicate process. When a star like our Sun reaches the end of its life, it swells into a red giant, engulfing nearby planets and scattering its outer layers into space. What remains is the star's core, a dense ball of carbon and oxygen that no longer undergoes fusion. This core, now a white dwarf, is incredibly dense. A teaspoon of its material would weigh as much as an elephant. Yet, despite their small size, white dwarfs pack a gravitational punch, with surface gravity hundreds of thousands of times stronger than Earth's. Over billions of years, white dwarfs cool and dim, gradually losing their heat and fading into black dwarfs, cold, dark remnants that no longer emit light. But this process takes so long that the universe isn't old enough for any black dwarfs to exist yet. For now, white dwarfs remain as faint beacons, their glow a testament to the stars they once were. Yet, even in their quiet state, white dwarfs can be dangerous. If a white dwarf orbits close to another star, it can siphon material from its companion, growing heavier until it reaches a critical limit. At this point, the white dwarf can explode in a cataclysmic event known as a Type I supernova. These explosions are so bright that they can outshine entire galaxies, and they play a crucial role in seeding the universe with heavy elements like iron and nickel. As we marvel at the beauty and mystery of white dwarfs, we're reminded that the universe is full of objects that defy our expectations. These fading embers of stars are a bridge between the past and the future, a glimpse into the final stages of stellar evolution. But the cosmos holds even more secrets, ones that are far more elusive and enigmatic. Beyond the glow of stars and the remnants they leave behind lies a shadowy force that shapes the very fabric of the universe, dark matter. And it's there, in the unseen depths of space, that our journey takes its next turn. In the vast tapestry of the cosmos, there's a force so mysterious that it defies detection yet shapes the very fabric of the universe. This is dark matter, an invisible substance that makes up roughly 85% of all matter in existence. Unlike the stars, planets, and gas clouds we can see, dark matter doesn't emit, absorb, or reflect light. It's completely invisible, yet its gravitational pull is so powerful that it holds galaxies together, sculpts the cosmic web, and dictates the fate of the universe itself. Imagine a galaxy like our Milky Way, its spiral arms glittering with billions of stars. What you're seeing is only a fraction of the story. Surrounding the galaxy is an enormous halo of dark matter, a ghostly presence that binds the stars and gas together, preventing them from flying apart. Without dark matter, galaxies would unravel, their stars scattering into the void like leaves in a storm. It's a silent architect shaping the universe on a scale that's almost impossible to comprehend. But how do we know dark matter exists if we can't see it? The answer lies in its gravitational effects. Astronomers have observed galaxies spinning so fast that, according to the laws of physics, they should tear themselves apart. The only explanation is that an invisible mass, dark matter, is holding them together. Similarly, the bending of light from distant galaxies, a phenomenon known as gravitational lensing, reveals the presence of massive, unseen structures in the cosmos. These clues point to a hidden world, one that's as beautiful as it is elusive. Despite decades of research, dark matter remains one of the greatest mysteries in science. Scientists have proposed countless theories, from weakly interacting massive particles, or WIMP, to exotic particles like actions. Yet, despite sophisticated experiments deep underground and in space, dark matter has never been directly detected. It's a cosmic puzzle that challenges our understanding of physics and forces us to rethink the nature of reality. The dangers of dark matter lie in its sheer dominance. Its gravitational influence doesn't just shape galaxies, it could determine the ultimate fate of the universe. Some theories suggest that dark matter might interact with itself in ways we don't yet understand, potentially leading to catastrophic events on a cosmic scale. Others speculate that it could play a role in the expansion of the universe, working in tandem with another mysterious force, dark energy, and that's where our journey takes us next. Dark energy, an even more enigmatic force, is driving the accelerated expansion of the universe, pushing galaxies apart at an ever-increasing rate. Together, dark matter and dark energy form the invisible framework of the cosmos, shaping its past, present, and future. But what exactly is dark energy, and how does it interact with the universe we see? The answers to these questions could change everything we know about the cosmos and our place within it. If dark matter is the invisible glue holding the universe together, then dark energy is the unseen force tearing it apart. This mysterious energy, making up about 68% of the universe, is driving the accelerated expansion of the cosmos, a discovery that turned our understanding of the universe on its head. Imagine the universe as a balloon inflating faster and faster, with galaxies racing away from each other as if pushed by an invisible hand. That hand is dark energy, a force so powerful that it's reshaping the very fabric of space-time. The story of dark energy's discovery begins in the late 1990s, when astronomers studying distant supernovae made a startling observation. These exploding stars, used as cosmic mile markers, were fainter than expected, suggesting they were farther away than previously thought. The only explanation was that the universe wasn't just expanding, it was accelerating. This revelation earned the researchers the Nobel Prize and opened a new chapter in cosmology, one filled with questions about the nature of this mysterious force. So, what exactly is dark energy? The truth is, we don't fully know. One leading theory suggests it's a property of space itself, often referred to as the cosmological constant. According to this idea, empty space isn't truly empty. It's filled with a kind of energy that pushes the universe apart. Another possibility is that dark energy is a dynamic field, changing over time and interacting with matter in ways we don't yet understand. Whatever it is, its effects are undeniable, shaping the large-scale structure of the cosmos and determining the ultimate fate of the universe. The beauty of dark energy lies in its role as a cosmic sculptor. On the grandest scales, it's responsible for the intricate web of galaxies and clusters we see today, stretching the universe into a vast, interconnected tapestry. Yet, this same force could also spell doom. If dark energy continues to accelerate the universe's expansion, it might one day lead to a big rip, tearing apart galaxies, stars, and even atoms in a catastrophic end to everything we know. But dark energy isn't the only force shaping the cosmos. While it works on the largest scales, other dramatic events, like cosmic collisions, play out on smaller, yet equally spectacular stages. These collisions, where galaxies, stars, and even black holes crash into one another, are some of the most violent and beautiful events in the universe. And it's there, in the chaos of these cosmic encounters, that our journey takes its next turn. In the vast expanse of the universe, where galaxies drift like islands in an endless sea, there are moments when these cosmic giants come together in a breathtaking dance. Picture two galaxies, each containing billions of stars, slowly spiraling toward one another, their gravitational pull drawing them closer until they merge in a spectacular collision. This isn't destruction, it's creation. As the galaxies intertwine, their stars and gas clouds swirl together, igniting bursts of new star formation and painting the cosmos with vibrant hues of light. It's a cosmic ballet where chaos gives birth to beauty on a scale that defies imagination. Galaxy mergers are more than just stunning visual spectacles, they're engines of cosmic evolution. When two galaxies collide, their gas clouds compress, triggering the birth of new stars and planets. These stellar nurseries light up the darkness, their glow a testament to the transformative power of these events. Over millions of years, the galaxy's structures are reshaped, their spiral arms stretched and twisted into new forms. What emerges is often a single, larger galaxy, its history written in the patterns of its stars and the glow of its newborn suns. But these mergers aren't without danger. At the heart of most galaxies lies a supermassive black hole, and when galaxies collide, so do their black holes. These titanic encounters send ripples through space-time, creating gravitational waves that echo across the universe. The collision of two supermassive black holes is one of the most violent events in the cosmos, releasing energy on a scale that's almost incomprehensible. Yet, even in this chaos, there's a strange kind of order. The merging black holes eventually settle into a single, more massive black hole, anchoring the newly formed galaxy and shaping its future. The beauty of galaxy mergers lies in their duality. They are both destructive and creative, tearing down old structures while building new ones. They remind us that the universe is a place of constant change, where even the most massive objects are not immune to the forces of gravity and time. And as we marvel at these cosmic collisions, we're left to wonder, what happens after the dust settles? What remnants are left behind? And what stories do they tell about the universe's past? The answers lie in the aftermath of these mergers, where the echoes of galactic encounters linger in the form of star clusters, tidal tails, and the faint glow of ancient light. These remnants are like cosmic fossils, preserving the history of the universe in their structures. And as we explore these traces of the past, we uncover even more about the forces that shape the cosmos. But that's a story for another time, one that takes us deeper into the mysteries of the universe's evolution. When galaxies collide, the aftermath is a cosmic masterpiece, a testament to the universe's ability to transform chaos into beauty. Among the most striking remnants of these collisions are elliptical galaxies, smooth, featureless spheres of stars that stand in stark contrast to the spirals we often picture. These galaxies are the end result of galactic mergers, their stars no longer arranged in delicate arms but instead orbiting in a chaotic yet harmonious dance. Imagine a galaxy that once sparkled with spiral elegance, now reshaped into a glowing, golden orb, its light a blend of countless stars from two once separate worlds. But the story doesn't end there. Galactic collisions also leave behind tidal tails, long, sweeping arcs of stars and gas that stretch far beyond the merged galaxy. These tails are like cosmic brushstrokes painted across the void by the gravitational forces of the collision. They're a reminder of the violence that created them, yet their graceful curves and shimmering light make them some of the most beautiful structures in the universe. In some cases, these tails can even give birth to new, smaller galaxies, turning destruction into creation once again. The science behind these remnants is as fascinating as their appearance. When two galaxies merge, their stars rarely collide. Space is simply too vast. Instead, their gravitational forces pull and twist the galaxy's structures, redistributing stars and gas into new patterns. Over time, the chaotic orbits settle into a more stable configuration, forming the smooth, rounded shape of an elliptical galaxy. Meanwhile, the tidal tails are created by the gravitational tug of war between the merging galaxies, stretching their outer regions into long, luminous streams. Yet, for all their beauty, these remnants are not without danger. The gravitational forces at play during a merger can disrupt entire star systems, flinging planets out of their orbits or sending them spiraling into the void. Even stars themselves can be torn apart, their light extinguished as they are consumed by the chaos. And at the heart of these collisions, supermassive black holes often merge, releasing bursts of energy that can sterilize entire regions of space. As we marvel at the remnants of galactic collisions, we're reminded that the universe is a place of constant change, where beauty and danger are intertwined. These structures tell the story of cosmic history, preserving the echoes of ancient encounters in their light and form. But the universe has even more dramatic tales to tell, stories of events so powerful they can outshine entire galaxies in an instant. And it's there, in the explosive brilliance of gamma-ray bursts, that our journey takes its next turn. Gamma-ray bursts are the universe's ultimate fireworks, explosions so powerful they outshine entire galaxies in a matter of seconds. These fleeting yet cataclysmic events release more energy in a single burst than our Sun will emit over its entire 10 billion-year lifetime. Imagine a flash of light so intense it can be seen from billions of light years away, a beacon cutting through the darkness of space. These bursts are not just spectacular, they're also some of the most mysterious phenomena in the cosmos, offering a glimpse into the extreme forces at work in the universe. The beauty of gamma-ray bursts lies in their afterglows. After the initial explosion fades, the burst leaves behind a lingering glow of X-rays, visible light, and radio waves. This afterglow can last for days, weeks, or even months, painting the sky with a fading echo of the explosion's brilliance. Astronomers use these afterglows to study the bursts, piecing together clues about their origins and the environments in which they occur. It's like watching the embers of a cosmic fire, each flicker revealing a piece of the puzzle. But what causes these titanic explosions? Gamma-ray bursts come in two main flavors, long and short. Long bursts, lasting from a few seconds to several minutes, are thought to result from the collapse of massive stars into black holes. As the star's core collapses, it sends out jets of energy at nearly the speed of light, creating the gamma-ray burst we observe. Short bursts, on the other hand, last only milliseconds and are believed to be caused by the collision of neutron stars or black holes. These violent mergers release a torrent of energy, sending shockwaves through space-time and lighting up the cosmos with their brilliance. Yet, for all their beauty, gamma-ray bursts are also harbingers of destruction. If one were to occur within a few thousand light-years of Earth, the intense radiation could strip away our ozone layer, exposing the planet to deadly ultraviolet rays from the sun. Such an event could trigger mass extinctions, sterilizing entire ecosystems in an instant. It's a sobering reminder of the universe's power and the fragility of life in the face of cosmic forces. As we marvel at the brilliance of gamma-ray bursts, we're reminded that the universe is a place of extremes where beauty and danger are often two sides of the same coin. But these bursts are just one piece of a much larger puzzle. Beyond the fleeting flashes of light lies a faint, ancient glow, a whisper from the dawn of the universe itself. This is the cosmic microwave background, the afterglow of the Big Bang, and it's there that our journey takes its next turn. The cosmic microwave background, or CMB, is like a whisper from the dawn of time, a faint glow that fills the universe and tells the story of its birth. Imagine a tapestry of light woven from the very first moments after the Big Bang, stretching across the cosmos and carrying the secrets of creation. This ancient radiation, invisible to the naked eye, is the afterglow of the universe's explosive beginning, a snapshot frozen in time when the cosmos was just a hot, dense soup of particles and energy. The beauty of the CMB lies in its simplicity and universality. It's a faint, almost imperceptible glow, detectable only with highly sensitive instruments, yet it permeates every corner of space. This radiation is the oldest light in the universe, dating back to just 380,000 years after the Big Bang, when the cosmos cooled enough for atoms to form and light to travel freely. Today, it appears as a uniform sea of microwaves, but subtle variations in its temperature, tiny fluctuations no larger than 100,000th of a degree, reveal the seeds of galaxies, stars, and planets. The discovery of the CMB in the 1960s was a turning point in cosmology. Two radio astronomers, Arno Penzias and Robert Wilson, stumbled upon this faint signal while trying to eliminate background noise from their antenna. What they initially thought was interference turned out to be the echo of the universe's birth, earning them the Nobel Prize and confirming the Big Bang theory. Since then, missions like the Cosmic Background Explorer, or COBE, and the Planck satellite have mapped the CMB in exquisite detail, providing a treasure trove of information about the universe's origins and evolution. Yet, for all its beauty, the CMB is not without its challenges. Detecting and interpreting this ancient signal requires cutting-edge technology and painstaking precision. The faintness of the radiation means that even the smallest interference, from Earth's atmosphere, the Sun, or even the instruments themselves, can obscure its subtle patterns. Scientists must sift through mountains of data, separating the cosmic signal from the noise, to uncover the secrets hidden within. The CMB is more than just a relic of the past, it's a window into the fundamental nature of the universe. Its patterns hint at the existence of dark matter and dark energy, the mysterious forces shaping the cosmos. They also raise profound questions about the universe's beginnings, its ultimate fate, and even the possibility of other realities beyond our own. And that's where the story takes an even more intriguing turn. The CMB's uniformity and subtle irregularities have led some scientists to speculate about the existence of multiverses, countless other universes, each with its own unique laws of physics, existing alongside our own. Could the CMB be a clue to a much larger cosmic tapestry, one that stretches far beyond the limits of our observable universe? The answer to that question lies in the realm of theoretical physics, where the boundaries of science and imagination blur. As we ponder the mysteries of the CMB, we're reminded that the universe is full of surprises, from the faintest whispers of ancient light to the boldest ideas about alternate realities. And as we explore these possibilities, we uncover even more about the cosmos and our place within it. The idea of a multiverse is like stepping into a cosmic kaleidoscope, a dazzling array of realities, each one a unique universe with its own set of rules, stars, and possibilities. Imagine not just one universe, but an infinite number of them, each existing alongside our own, separated by dimensions we can't see or touch. This concept, born from the frontiers of theoretical physics, stretches our understanding of reality to its limits, offering a vision of existence that's as beautiful as it is mind-bending. At the heart of the multiverse theory lies the idea that our universe might be just one bubble in a vast cosmic foam. One of the leading explanations comes from inflationary cosmology, which suggests that the rapid expansion of the early universe didn't happen just once but countless times, creating a multitude of universes, each with its own distinct properties. Another theory, rooted in string theory, proposes that our universe is one of many brains floating in a higher dimensional space, occasionally brushing against one another in ways we can't yet detect. These ideas aren't just science fiction, they're serious scientific hypotheses, backed by complex mathematics and observations of the cosmic microwave background. The beauty of the multiverse lies in its infinite possibilities. In one universe, the laws of physics might allow for stars that burn forever. In another, life might thrive in forms we can't even imagine. Some universes could be eerily similar to ours, with only slight differences, like a world where dinosaurs never went extinct. Others might be so alien that they defy all logic and reason. It's a concept that sparks the imagination, inviting us to ponder what lies beyond the boundaries of our own reality. Yet, for all its wonder, the multiverse also carries a sense of danger. If other universes exist, some might be hostile or incompatible with our own. Collisions between universes could trigger catastrophic events, reshaping entire realities in an instant. Even the idea of infinite possibilities raises unsettling questions. What if there's a universe where every choice we make plays out in every possible way? The multiverse challenges not just our understanding of physics, but our sense of identity and purpose. As we explore the multiverse, we're reminded that the universe, or universes, are far stranger and more complex than we ever imagined. But while the multiverse remains a tantalizing idea, it's not the only mystery that captivates us. Beyond the boundaries of our reality lies another question, one that has fascinated humanity for centuries. Are we alone in the cosmos? The search for extraterrestrial life takes us beyond the multiverse, into the realms of planets, stars, and the possibility of life beyond Earth. And it's there, in the quest to find our cosmic neighbors, that our journey continues. The question of whether we are alone in the universe is one of the most profound and enduring mysteries of all time. For centuries, humanity has gazed at the stars, wondering if somewhere out there, another civilization might be looking back. This search for extraterrestrial life is not just a scientific endeavor. It's a journey that touches the very core of our curiosity and imagination. From the discovery of life thriving in Earth's most extreme environments to the exploration of distant exoplanets, the quest to find life beyond our world is as beautiful as it is complex. One of the most fascinating aspects of this search is the discovery of extremophiles organisms that survive in conditions once thought impossible for life. From the scorching heat of hydrothermal vents at the bottom of the ocean to the frozen deserts of Antarctica, these resilient creatures have expanded our understanding of where life can exist. If life can thrive in such harsh environments on Earth, why not on the icy moons of Jupiter or the methane lakes of Titan? Extremophiles have opened our eyes to the possibility that life might be far more adaptable and widespread than we ever imagined. To detect signs of life beyond Earth, scientists look for biosignatures, chemical or physical markers that indicate the presence of living organisms. These could include oxygen in a planet's atmosphere, methane produced by microbial life, or even the faint glow of chlorophyll on a distant world. But biosignatures aren't the only clues. Technosignatures, such as radio signals or megastructures, could point to the existence of intelligent civilizations. Projects like SETI, the search for extraterrestrial intelligence, scan the skies for these signals, hoping to catch a whisper from another world. Yet, the search for extraterrestrial life is not without its dangers. The possibility of encountering a hostile alien civilization, while thrilling, raises ethical and existential questions. How would humanity respond to contact with a species far more advanced or far more aggressive than our own? The risks are as vast as the cosmos itself, reminding us that the search for life is not just about discovery, but also about understanding our place in the universe. As we push the boundaries of our knowledge, the next frontier becomes clear: interstellar travel. The idea of traveling to distant stars, once the realm of science fiction, is now a topic of serious scientific discussion. But the challenges are immense. The vast distances between stars, the limitations of current propulsion technology, and the need to sustain life during long voyages are just a few of the hurdles we must overcome. Yet the dream of reaching another world, and perhaps finding life there, continues to inspire us, driving humanity to explore the cosmos like never before. And as we look to the stars, we're reminded that the search for extraterrestrial life is more than a scientific quest. It's a reflection of our deepest hopes, fears, and dreams. It's a journey that challenges us to think beyond our own world, to imagine what might lie beyond the horizon, and to ask the ultimate question: are we alone? The answer, whatever it may be, will change everything. The dream of interstellar travel has long captured the human imagination, a vision of venturing beyond our solar system to explore distant stars and the worlds that orbit them. Picture a spacecraft gliding through the void, its engines powered by technologies we've yet to invent, carrying humanity to the far reaches of the galaxy. It's a vision of hope and discovery, one that promises to unlock the secrets of the cosmos and perhaps even find new homes among the stars. But as beautiful as this dream is, the reality of interstellar travel is fraught with challenges that push the boundaries of science, engineering, and human endurance. The first and most daunting hurdle is distance. The nearest star system, Alpha Centauri, lies over 4 light-years away, a journey that would take tens of thousands of years with current propulsion technology. To bridge this gap, scientists are exploring advanced concepts like nuclear propulsion, solar sails, and even theoretical ideas such as warp drives. These technologies, while still in their infancy, offer a glimmer of hope for reducing travel times to a matter of decades or even years. Yet, even with breakthroughs, the sheer scale of interstellar space remains a humbling reminder of the universe's vastness. Another challenge is the harsh environment of space itself. Cosmic radiation, a constant barrage of high-energy particles, poses a serious threat to both spacecraft and crew. Without adequate shielding, prolonged exposure could lead to radiation sickness, increased cancer risks, and damage to sensitive electronics. Then there's the psychological toll of long-duration spaceflight. Imagine spending years or even decades in the confined quarters of a spacecraft, isolated from Earth and the people you love. The mental strain of such a journey is as much a barrier as the physical challenges, requiring innovative solutions to keep crews healthy, motivated, and connected. Despite these obstacles, the allure of interstellar travel continues to inspire. The possibility of discovering new worlds, perhaps even finding signs of life, drives scientists and dreamers alike to push the boundaries of what's possible. Missions like Breakthrough Starshot aim to send tiny, light-powered probes to Alpha Centauri within a generation, while concepts for generational ships, vast vessels designed to sustain human life over centuries, offer a glimpse of what might one day be achievable. As we look to the stars, we're reminded that the journey itself is as important as the destination. Interstellar travel isn't just about reaching new worlds, it's about expanding our understanding of the universe and our place within it. And as we dream of the stars, we're also shaping the future of space exploration, a future that holds even more possibilities for discovery and adventure. But what does that future look like? From the development of new technologies to the exploration of our own solar system, the next chapter in humanity's journey into space is already being written. And it's there, in the unfolding story of space exploration, that our adventure continues. The future of space exploration is a canvas of infinite possibilities, painted with dreams of lunar bases, Martian colonies, and voyages to the farthest reaches of our solar system. Imagine stepping onto the surface of the moon, not as a fleeting visitor, but as part of a thriving community where habitats rise from the dusty regolith and greenhouses bloom under the light of Earth. Or picture a bustling colony on Mars, its red plains dotted with domed cities and rovers, as humanity takes its first steps toward becoming a multi-planetary species. These aren't just science fiction fantasies, they are goals within our reach, driven by a blend of ambition, innovation, and necessity. What makes these endeavors so captivating isn't just the technology behind them, but the profound beauty of expanding our horizons. Establishing a presence beyond Earth isn't just about survival, it's about growth. It's about pushing the boundaries of what it means to be human, exploring new frontiers, and ensuring that our species endures no matter what challenges Earth may face. The idea of looking up at the night sky and knowing that somewhere out there people are living, working, and thriving on another world is a vision that stirs the soul. To make these dreams a reality, scientists and engineers are developing groundbreaking technologies, from reusable rockets like SpaceX's Starship to advanced life support systems that recycle air and water. The tools of tomorrow are being forged today. Lunar bases could serve as testing grounds for sustainable living, using local resources like water ice to produce oxygen and fuel. Mars colonies might rely on 3D printed habitats built from the planet's own soil and powered by solar arrays that stretch across the rusty landscape. These innovations aren't just about survival, they're about creating a future where humanity thrives among the stars. Yet, the path to the stars is fraught with danger. Space travel itself is a perilous endeavor, with risks ranging from radiation exposure to the psychological toll of isolation. Colonizing other worlds raises ethical questions too. How do we ensure that our presence doesn't harm potential extraterrestrial ecosystems? What responsibilities do we have to preserve the pristine environments of other planets? These challenges remind us that exploration isn't just about reaching new places, it's about doing so thoughtfully, with respect for the cosmos and its mysteries. Despite the risks, the allure of space exploration lies in its ability to inspire. It's a reminder that humanity's greatest strength is its curiosity, its drive to explore the unknown and push beyond the limits of what's possible. Space isn't just a destination, it's a source of wonder, a place where the boundaries of science and imagination blur. And as we look to the stars, we're reminded that the universe is vast, full of beauty and danger waiting to be discovered. But the future of space exploration isn't just about the destinations, it's about the journey. It's about the technologies we'll invent, the challenges we'll overcome, and the stories we'll tell. And as we dream of lunar bases and Martian colonies, we're also shaping the future of humanity one step at a time. The cosmos beckons not just as a frontier to conquer, but as a source of endless inspiration, inviting us to explore, to wonder, and to dream. Space has always been more than just a backdrop for scientific discovery. It's a source of inspiration that transcends boundaries, igniting creativity, curiosity, and a deeper understanding of our place in the universe. From the swirling colors of distant nebulas to the stark, fragile beauty of Earth seen from orbit, the cosmos has a way of stirring something profound within us. It's a reminder that we are part of something vast, interconnected, and infinitely mysterious. One of the most transformative experiences for astronauts is the overview effect, a profound shift in perspective that occurs when viewing Earth from space. Imagine looking out of a spacecraft window and seeing our planet suspended in the void, a delicate blue marble wrapped in swirling clouds and oceans. In that moment, borders vanish, and the divisions that seem so significant on the ground fade into irrelevance. Astronauts often describe this experience as life-changing, sparking a deep sense of unity and responsibility for our shared home. It's a perspective that has inspired countless works of art, from paintings and poetry to music and film, all attempting to capture the awe and humility of seeing Earth as a single, fragile entity. But the inspiration drawn from space isn't limited to art. It fuels scientific innovation, pushing humanity to solve problems and create technologies that once seemed impossible. The challenges of space exploration, like developing life support systems, radiation shielding, and sustainable energy sources, have led to breakthroughs that benefit life on Earth. From satellite technology that connects the globe to medical advancements born from space research, the ripple effects of our cosmic ambitions are felt in nearly every aspect of modern life. Yet, for all its beauty and potential, space also carries a darker side. The same vastness that inspires wonder can also tempt exploitation. As nations and private companies race to mine asteroids, colonize planets, and claim celestial resources, questions arise about who gets to benefit and who gets left behind. The potential for conflict over space's riches is a sobering reminder that even in the stars, humanity's flaws can follow. This duality, the beauty and danger of space, forces us to confront not just the technical challenges of exploration, but the ethical ones as well. How do we ensure that space remains a realm of discovery and unity, rather than division and greed? These questions are at the heart of the next chapter in humanity's journey into the cosmos, where the stakes are as high as the stars themselves. And as we grapple with these ethical dilemmas, we're reminded that space is more than a frontier. It's a mirror, reflecting both our greatest aspirations and our deepest challenges. It's a call to think beyond ourselves, to dream bigger, and to strive for a future where the cosmos inspires not just exploration, but also wisdom and compassion. But what does that future look like? How do we balance the drive to explore with the need to protect and preserve? These are the questions that will shape the next era of space exploration, and it's there, in the realm of ethics and responsibility, that our journey continues. As humanity reaches further into the cosmos, we're faced with a profound question. How do we explore responsibly? Space isn't just a frontier for discovery. It's a realm of immense beauty and fragility, one that demands careful stewardship. The ethical considerations of space exploration go beyond the technical challenges, touching on how we treat extraterrestrial environments, the potential for encountering life, and the need to preserve the pristine nature of worlds we've yet to fully understand. Take, for example, the concept of planetary protection. This principle, embraced by space agencies worldwide, aims to prevent contamination of other planets and moons with Earth's microbes and vice versa. It's not just about safeguarding scientific integrity, it's about respecting the potential for life elsewhere in the universe. Imagine landing on Europa, Jupiter's icy moon, only to discover that our own spacecraft have introduced earthly bacteria, forever altering its pristine environment. The beauty of planetary protection lies in its humility, reminding us that exploration isn't just about what we can take, but what we can preserve. But the ethical challenges don't stop there. As nations and private companies set their sights on mining asteroids or colonizing Mars, questions arise about who gets to benefit from these endeavors. Will space become a new frontier for exploitation, or can it remain a shared heritage for all humanity? The potential for environmental harm is real. Strip mining an asteroid, for instance, could disrupt delicate cosmic balances, while unchecked colonization might irreversibly alter the landscapes of other worlds. These risks highlight the need for international cooperation, ensuring that space exploration is guided by principles of fairness, sustainability, and respect. The dangers of failing to address these ethical questions are significant. Without clear guidelines, space could become a battleground for geopolitical tensions, with nations vying for control over resources or strategic advantages. The beauty of space lies in its ability to unite us, offering a perspective that transcends borders and divisions. But if we're not careful, it could also become a source of conflict, undermining the very unity it inspires. At its core, responsible space exploration is about balancing the drive to discover with the need to protect, balancing ambition with humility, and balancing national interests with global cooperation. It's a reminder that space isn't just a place to conquer, but a shared heritage that belongs to all of humanity. And as we venture further into the cosmos, this perspective will shape not just how we explore, but who we become as a species. This brings us to the heart of the matter, space as a shared heritage. It's a concept that challenges us to think beyond ownership and exploitation, to see the cosmos as a common treasure that transcends individual ambitions. And as we grapple with these ideas, we're reminded that the future of space exploration isn't just about reaching new worlds. It's about doing so with wisdom, responsibility, and a deep respect for the universe we call home. But what does that future look like? How do we ensure that space remains a source of inspiration and unity, rather than division and conflict? These are the questions that will guide the next chapter of our cosmic journey, as we strive to explore not just with curiosity, but with care. Space is not just a frontier for exploration, it's a shared heritage, a treasure that belongs to all of humanity. Imagine the cosmos as a vast, open library, where every star, planet, and galaxy holds stories waiting to be discovered. But unlike a library, space has no borders, no ownership. It's a realm that transcends nations, cultures, and ideologies, reminding us that we are all passengers on the same pale blue dot. This idea of space as a global endeavor is both beautiful and essential, shaping how we explore, collaborate, and protect the final frontier. One of the most inspiring examples of this shared heritage is the International Space Station, or ISS. Orbiting Earth at over 17,000 miles per hour, the ISS is a testament to what humanity can achieve when we work together. Built and operated by a coalition of nations including the United States, Russia, Japan, Canada, and European countries, the ISS is more than just a scientific laboratory. It's a symbol of unity, a place where astronauts from different backgrounds live and work side by side, conducting experiments that benefit all of humanity. The station's very existence proves that even in a world often divided, space can bring us together. Yet, the beauty of international collaboration comes with its own set of challenges. As more nations and private entities set their sights on space, questions of equity and access arise. Who gets to explore the Moon, Mars, or the asteroids? How do we ensure that the benefits of space exploration are shared fairly, rather than monopolized by a few? These questions are at the heart of the debate over space governance, a complex web of treaties, agreements, and policies designed to keep space peaceful and accessible. The Outer Space Treaty of 1967, for example, declares that space is the province of all mankind, but enforcing this principle in an era of rapid technological advancement is no easy task. Another pressing concern is the militarization of space. While the Outer Space Treaty prohibits the placement of weapons of mass destruction in orbit, it doesn't fully address the growing use of satellites for military purposes or the development of anti-satellite weapons. The risk of conflict in space is real, with the potential to disrupt communication, navigation, and even scientific research. The debris from a single destroyed satellite could create a cascade of collisions, rendering entire orbits unusable, a scenario known as the Kessler syndrome. Preventing such a catastrophe requires not just international cooperation, but a shared commitment to keeping space a zone of peace. Sustainability is another critical issue. As we venture further into the cosmos, we must ensure that our activities don't harm the very environments we seek to explore. This means developing technologies that minimize waste, reduce pollution, and protect celestial bodies from contamination. It also means thinking long-term, considering how our actions today will shape the future of space exploration for generations to come. The idea of space as a shared heritage is both inspiring and humbling. It challenges us to think beyond national interests and short-term gains, to see the cosmos as a common resource that belongs to everyone. But as we strive to uphold this vision, a new player has entered the arena: private companies. With their ambitious goals and rapid innovations, these entities are reshaping the landscape of space exploration and raising new questions about who gets to shape the future of the final frontier. And it's there, in the rise of private space ventures, that our journey takes its next turn. The rise of private space companies has ushered in a new era of exploration, one where the stars are no longer the exclusive domain of governments. Companies like SpaceX, Blue Origin, and others are redefining what's possible, turning science fiction into reality with ambitious goals that capture the imagination. Picture a future where humans live on Mars, where asteroids are mined for precious resources, and where space travel becomes as routine as flying across the globe. These companies aren't just dreaming big, they're building the rockets, habitats, and technologies to make it happen. What makes this new space race so exciting is the sheer scale of its ambition. SpaceX, founded by Elon Musk, aims to establish a self-sustaining colony on Mars, a vision that could one day ensure humanity's survival beyond Earth. Blue Origin, led by Jeff Bezos, envisions millions of people living and working in space with massive orbital habitats powered by solar energy. Meanwhile, companies like Planetary Resources are looking to the asteroid belt, where they hope to mine metals and water, turning space into a resource-rich frontier. These goals aren't just about exploration, they're about transforming humanity's relationship with the cosmos. The benefits of private sector innovation are undeniable. By introducing competition and cutting-edge technology, companies like SpaceX have dramatically reduced the cost of launching payloads into space. Reusable rockets, once a pipe dream, are now a reality, slashing expenses and opening the door to more frequent and affordable missions. This democratization of space access has sparked a wave of creativity, enabling smaller nations, universities, and even private citizens to participate in space exploration. It's a shift that's making the cosmos more accessible than ever before. Yet, with great opportunity comes great risk. The profit-driven nature of private companies raises concerns about exploitation. Will the rush to mine asteroids or colonize Mars prioritize short-term gains over long-term sustainability? Regulatory challenges also loom large. Who sets the rules for space mining or planetary settlements? Without clear guidelines, the new space race could devolve into a free-for-all, with environmental and ethical consequences that ripple across the solar system. Amid these challenges, another frontier is emerging: space tourism. Imagine boarding a spacecraft not as an astronaut but as a tourist, gazing out at Earth from the edge of space or floating in zero gravity. Companies like Virgin Galactic and Blue Origin are already making this a reality, offering suborbital flights that promise a taste of the cosmos. While these experiences are currently reserved for the wealthy, they represent a step toward a future where space travel is within reach for more people. But space tourism isn't just about luxury, it's about perspective. Seeing Earth from above has a profound effect, often described as the overview effect, a shift in awareness that highlights our planet's fragility and interconnectedness. As more people experience this, it could inspire a deeper commitment to protecting our home, even as we reach for the stars. The rise of private space companies is a double-edged sword, blending the beauty of human ambition with the dangers of unchecked exploitation. As we navigate this new frontier, the choices we make today will shape the future of space exploration and our place within it. And as we look to the stars, we're reminded that the cosmos is not just a destination, but a reflection of who we are and who we aspire to be. But what does this mean for the average person? How will the innovations of private companies impact our daily lives, and what role will we play in this cosmic journey? These are the questions that will guide the next chapter of our exploration. as we delve into the ways space technology is already shaping life on Earth. Space tourism is no longer the stuff of science fiction. It's a reality on the horizon, offering ordinary people the chance to experience the wonders of the cosmos firsthand. Imagine strapping into a sleek spacecraft, feeling the rumble of engines as you ascend through the atmosphere, and then, in a breathtaking moment, gazing down at Earth from the edge of space. The vision of space tourism is as beautiful as it is revolutionary, promising to make the stars accessible not just to astronauts, but to anyone with a sense of adventure and a ticket to ride. At the forefront of this new frontier are companies like Virgin Galactic and Blue Origin, pioneers in the race to turn space travel into a commercial industry. Virgin Galactic's Spaceship Two, for example, is designed to carry passengers on suborbital flights, offering a few minutes of weightlessness and a view of Earth that few have ever seen. Blue Origin's New Shepard, meanwhile, takes a similar approach, with its reusable rocket system making space tourism more sustainable and cost-effective. These companies aren't just building rockets, they're crafting experiences, turning the dream of space travel into something tangible and real. But the beauty of space tourism comes with its own set of challenges. For passengers, the risks are significant. Space travel is inherently dangerous, with the potential for mechanical failures, extreme G-forces, and the harsh environment of space itself. Even a minor malfunction could have catastrophic consequences, a reminder that venturing beyond Earth's atmosphere is never without peril. And then there's the environmental impact. Frequent rocket launches contribute to atmospheric pollution, releasing greenhouse gases and particles that could harm the ozone layer. As the industry grows, finding ways to minimize this impact will be crucial to ensuring that space tourism doesn't come at the expense of our planet. Despite these challenges, the allure of space tourism is undeniable. It's not just about the thrill of weightlessness or the awe-inspiring views, it's about shifting our perspective. Astronauts often describe the overview effect, a profound sense of connection and responsibility that comes from seeing Earth as a fragile, borderless whole. For space tourists, this experience could spark a deeper appreciation for our planet and a renewed commitment to protecting it. As we look to the future, space tourism is just the beginning. It's a stepping stone toward a larger vision, one where humanity doesn't just visit space, but lives and thrives among the stars. The technologies and experiences being developed today could pave the way for lunar vacations, Martian colonies, and even interstellar journeys. But what does that future look like? How will humanity adapt to life beyond Earth? And what challenges will we face as we take our first steps toward becoming a spacefaring species? These are the questions that will shape the next chapter of our cosmic journey. The long-term future of humanity in space is a vision that blends ambition, wonder, and a touch of the unknown. Imagine a time when our species isn't confined to Earth, but thrives across the solar system and beyond, living on Mars, mining asteroids, and perhaps even venturing to distant stars. This dream of becoming a spacefaring civilization isn't just about survival. It's about expanding our horizons, pushing the boundaries of what it means to be human, and ensuring that our story continues, no matter what challenges Earth may face. At the heart of this vision lies the beauty of possibility. Picture a Martian colony, its domed habitats glowing under a dusty red sky, with greenhouses brimming with crops grown in alien soil. Or envision a bustling outpost on the Moon, where lunar ice is harvested to produce oxygen and fuel, turning a barren landscape into a hub of activity. These aren't just science fiction fantasies, they're tangible goals, driven by advances in technology and a growing understanding of how to live sustainably in space. The idea of humanity spreading its wings, planting roots on other worlds, and exploring the cosmos is a testament to our ingenuity and resilience. But this future isn't without its challenges. Living in space requires more than just advanced technology. It demands a fundamental shift in how we think about sustainability. On Earth, we take for granted the abundance of air, water, and food. In space, every resource must be carefully managed, recycled, and reused, building habitats that can withstand radiation, extreme temperatures, and the psychological strain of isolation is no small feat. The mental health of spacefarers is another critical concern. Imagine spending years in a confined environment far from the comforts of home with only a handful of companions for company. The psychological effects of such isolation could be profound, requiring innovative solutions to keep morale high and minds healthy. And then there are the dangers. The potential for societal collapse in a space colony is a real risk. A single failure in life support systems, a misstep in resource management, or even interpersonal conflict could spell disaster. The ethical dilemmas of altering other worlds also loom large. Should we terraform Mars, reshaping its environment to suit our needs, or should we preserve its pristine state, respecting it as a unique part of the cosmos? These questions force us to confront not just the technical challenges of space exploration, but the moral ones as well. Yet, despite these challenges, the dream of becoming a spacefaring civilization remains a powerful one. It's a vision that unites us, reminding us of our shared humanity and our capacity to overcome even the most daunting obstacles. As we reflect on the journey through the most beautiful and dangerous places in space, we're reminded that the cosmos is both a source of inspiration and a call to action. It challenges us to dream bigger, to think beyond our own world, and to strive for a future where humanity's story continues among the stars. But what does that future look like in practical terms? How do we turn this vision into reality, and what steps must we take to ensure that our journey into space is not just successful but sustainable and ethical? These are the questions that will guide the next chapter of our exploration, as we delve into the technologies, policies, and philosophies that will shape humanity's destiny in the cosmos. As we come to the end of this cosmic journey, it's impossible not to feel a profound sense of wonder. From the swirling, kaleidoscopic beauty of nebulas where stars are born in clouds of gas and dust, to the cataclysmic brilliance of supernovas, which scatter the building blocks of life across the universe, space has shown us its capacity for both creation and destruction. We've marveled at the eerie glow of neutron stars, the gravitational might of black holes, and the explosive power of gamma-ray bursts, each one a reminder of the universe's dual nature, breathtakingly beautiful and unimaginably dangerous. This duality is what makes space so captivating. It's a realm where the laws of physics push the boundaries of what we thought possible, where light bends, time slows, and matter is compressed into unimaginable densities. Yet, for all its grandeur, space is also a place of fragility. The same forces that sculpt galaxies and ignite stars can also obliterate planets and sterilize entire star systems. It's a delicate balance, one that inspires both awe and humility. But the story of space isn't just about distant phenomena, it's about us. It's about humanity's insatiable curiosity, our drive to explore the unknown, and our ability to find beauty in the most unexpected places. Whether through the lens of a telescope, the brushstrokes of an artist, or the pages of a science fiction novel, the cosmos invites us to dream, to question, and to imagine. As Carl Sagan once said, "The cosmos is within us, we are made of star stuff." This profound truth reminds us that we are not separate from the universe, but an integral part of it. Every atom in our bodies, every breath we take, is a product of the stars. And just as the stars have shaped us, we, in turn, have the power to shape our understanding of the cosmos. So, as we close this chapter, I encourage you to keep exploring. Whether it's through stargazing, reading about the latest discoveries, or simply letting your imagination wander among the stars, the universe is waiting for you. Share your thoughts in the comments below. What part of this cosmic journey resonated with you the most? And if you enjoyed this adventure, don't forget to subscribe for more explorations into the wonders of space. Finally, let's take a moment to reflect on Sagan's iconic words from Pale Blue Dot. Look again at that dot. That's here, that's home, that's us. In the vastness of space, Earth is but a tiny speck, a fragile oasis in the cosmic ocean. Yet it's our home and it's worth protecting. As we continue to explore the stars, let's also remember to cherish the pale blue dot we call home. Thank you for joining me on this journey through the most beautiful and dangerous places in space. Until next time, keep looking up and keep dreaming.